Is it back?
Yes.
Okay. Otherwise. Yeah, the group I took a lot, take it time. Again, like it's 2 million nodes and
3 million nodes? 2 million?
Sorry, 3 million nodes, but it's a 2 millions like 2 million rows practically. So and the CPU is not easy. Any question meanwhile? Because I remember it's like it was one of those things take time. I could sample it, but I decided not to. I sampled it a lot. The first plot I made with everything was 9 million something nodes. I reduced it to 3 million.
I have a question. So,
Yes.
how did you know to take a ratio here? Like, what was the?
Oh, I did. I just did everything.
Sorry.
I feel I did everything.
Okay.
So we again, some of these things that you just want to see to come up with the metrics that shows difference between the like PageRank sender and PageRank of the recipient, right? So there are lots of methods that, like PageRank, as I said, like PageRank is heavily used in cybersecurity as well. Like in my presentation, like there are lots of for web spam detection. So these are trust rank, spam rank, anti-rank. Most of them use PageRank as their main source of truth, and then like each of them use different weighting processes or different comparison between the ranks as their techniques, right? So there are so many techniques. You can just intuitively talk about it, just like, or go and like see like how it works. It could be cosine distance, it could be distance, it could be differences, it could be ratio. The ratio is just, the idea behind it was, if the ratio like, if the fraudulent person should have, it's just like, the ratio should be different. Like the number of the ones you want to catch, the PageRank should be some sort of different.
Like trustworthy people should have a very high PageRank,
yeah,
and untrustworthy people should have a low PageRank. But we don't really care if an untrustworthy person is interacting with an untrustworthy person, but we do care about when good and bad collide.
Yeah.
I guess.
Yeah, 5%. That was a good answer. Very shorter than what I was on mine. But again, like, it was some sort of experiment. We were trying to do experiment, and I think it shows like we landed up to this because it shows the distinct. It obviously says, okay, this is something here fishy going on. Any other questions?
A bit of a dumb question. In the spam example, what are the edges of the graph?
So, which is a very good question. It's a website's rank, like the.
Oh, so looking at like maybe the links. In
the links
Yeah.
between websites and how they are trusted or not.
Oh.
So it's like, you can think of it as the graph can be seen as a transition matrix. So if you started off with a random vector of, the probability that you went to any website, and then you multiply that vector by that matrix, and you do it again and again and again and again and again, eventually that you'll end up in a steady state, which is going to be one of the eigenstates of this transition matrix. And that sorry, I get really nerdy about this stuff, but then the most populous, the most likely websites that you'll end up in are going to be at the top, and the least likely are in the bottom.
No, I get that. It's just, you always have to formulate the problem as a graph.
Yeah.
And apply the algorithm.
Oh yeah, yeah.
So like with this, like if I get an email from, someone suspicious, it's just a, individual email. So like what's the equivalent, like the vertices and edges in the graph?
So
But
it's
you're
just
saying
probably
look
with
in
the
the
number
email,
of the click it's
look in the email and see what website is it trying to direct me to?
Or you could even look at the email address, couldn't you? Like,
It depends. It's very depends on the like these ones. I think it's just like it's because of the number of redirects your web page goes. Like these are the a little bit older version of them. If you remember, there might be still like if you go to the pages, it was lots of fake advertisement, and oh you want that, oh you go there, and there were tons of redirects. Like this one based on those, like how many redirects it goes to that. For phishing, as you said, like the emails, it could be.
how many outbound emails are going to this address versus
Yeah, like they have to add like. I'm thinking like how many outbound email going there, how many clicks going there, again how many redirects goes there, because like they usually, although you know the redirects, right? How many times the redirects, and then what's the how many times that somebody in your network touched that web page, trustworthy, and obviously you should have lots of white noise and like white list of data as well. It probably looks at the headers of the
Question from online.
yeah, sorry. Yeah, like I'm still. It looks at the
sorry.
metadata of your like JavaScript and something, and like looks at those information as well. Right. But the short answer is like I'm just don't know exactly what all this. Yeah.
Okay.
Oh, it's done.
The question is, I'm curious to know what the most advanced visualization tools leading organizations are using for interactive graphs. It can be only what we're seeing in the example.
So like it can be what?
Like, I think he thinks what we're seeing is too simplistic, too simple. He's curious, like, what are some of the advanced visualization tools that some organizations are using?
So there are lots of like visualization tools that different teams using. Like Neo4j is that. GraphStack, I believe, is one of those. There is
They're just using Python, NumPy, right?
sorry, I didn't hear.
I know what you're saying. You guys saw that.
It's not between me. It's between something. Yeah, it's like Tableau is one of those. Like Django, I believe, is one of the. Yeah, D3 is D3 is a very good one. Yeah. Yeah, actually, yeah, interactive ones as well. People love D3. I use it for matrix factorization. It was really good. I was enjoying. Yeah. Yeah, exactly. There are tons of them. Like yeah, NumPy. It depends, like how you are good at Python. Like Matplotlib is very strong, but it takes forever to visualize. Also,
Plotly, but it's not great for graphs, I'll be honest.
yeah, Plotly is not right. I think Neo4j, GraphStack are the ones I know graph related. DS3 is a good suggestion, and IBM has some graph like visualization, like something like Neo4j. I cannot recall it. They have like I cannot remember the name, but they have something similar.
Okay.
As well. But reality is, except you show this type of the graph very few times. You don't need to see the graph itself. You show it to business, you show it, but it's, that big graphs, you don't need to show it, or we don't show it, right? To be honest, like we just show a snapshot of it, or like some sort of snapshot. So back to this. Any other question online? Actually, another PageRank is coming, so like we have time. Did I back? No. So again, like I group by, this is how it's look like. I'll take a logarithmic. For some reason, because there were 0 amounts sent and like there were 0 amounts,
the value of 0, I just add a $1 here to not get any error. That's it. We go to, now we are generating, so now we have new data frame, generating weighted PageRank. So we have to generate new graph based on this information, and the edge would be now log of the amount, and then after that we go and generate weighted PageRank. So now we again generate graph. It's a little bit shorter time needs to generate graph here, because now we group by, we have a little bit shorter list of sender and recipient, and yeah, it takes a little bit time. Any other questions? So another thing that I'm not showing it here is connected component. I'm gonna call it connected components. Yeah, strongly connected components of the graph is another feature that shows like how nodes are close to each other or sent like far away from each other. That's a good again, like if the node from one community goes to other community is a good example of there's something fishy is going on. There are so many different features in the graph can tells you there's something fishy, and you eventually can add them together and make it one big view, or you just can go one by one to get the insight as well. Like, it just depends on what you want to get out of the graph analysis here.
Strongly connected components are two really good examples because they're not, it's not an ideal algorithm. So an ideal algorithm would be like a clique, like find the fully connected group within this network. But there's two problems with that. One, I mean, you're assuming that everybody has to be connected, which is not necessarily the case. But the second one is that's actually an NP hard problem. That is a very difficult thing to find.
Yeah, it takes forever to run.
So strongly connected components is a more optimized algorithm, less complex. And yeah.
Yeah, but reality is our data is complex, right? We cannot easily use information, take information out of those data, especially again, like something like, I would say, insurance for you guys. It's very more complex than like something like email money transfer, because you even know how to connect things together, right? How even know where to look at. And I still think like graph is a good idea. Like, it gives you idea, at least that at minimum gives you idea of where you should look, where is the fishy part you should start, right? And then you can build the models and the component out of it. But we use graph in like lots of our projects, like from detecting frauds, detecting anomaly accesses, detecting like recommendation system. We use it like in different parts of our work, and I know where we use it. I was thinking like how we can mask the information. Yeah, and we always get the successful results out of it, right? It's more efficient than so many other models, and it's always successful. Okay, now we have PageRank. They're similar to before. We define the distances. It just takes a little bit of time, and we plot. So this is the place I realized the data is not really good data. It's because like we see very similar behavior to before. In normal data, you wouldn't see that. Weighted PageRank always gives you more granular results. Like when I reached that, I was like, okay, like at this stage, I was like, either I have to start everything from beginning or accept the fact that you trust me that weighted PageRank would give you more granular results. This is not real data. This is synthesis. I'll point out so many like issue this data has, but in the real world data, you would see difference in here, especially in here. in the so like it's like it gives you a little bit different view on here. So I mean, like this is like it's a big block of information. Like you cannot get any information, but it gives you like some view around this area if you test it on the real data. The other thing I wanted to talk about, first of all, it took forever to run, and yeah, it took forever to run. I tried the whole thing. It's using Deepwalk for graph embedding. This is like I put the code here because the code I find is one of the best one you can see. Like so, you can go and like analyze it by yourself. It runs a job. Like as you can see in my computer, it finishes. Oh, sorry. Oh, the whole process.
Powered by kinetic energy.
Share, hide, present. Yep, very good. So, here. So it finishes the job. So it just takes. I ran it. I went for interview and came back. So I don't know how long does it take. Like, but it finished the job. It used a Deepwalk to embed to generate the features, and you can use this feature for your model. But another thing you can do is you can just use PageRank, second shortest path, Ego network, EgoNets, and some sort of in-degree out number of in-degree, out-degree information for your like decision tree, and pass all those information for a decision tree, and I guarantee you get a good results. I have seen so many papers, and maybe in real life that you get the good results.
Is it like is it too naive to like take like just a neural network, maybe a CNN, and feed the graph like in matrix form to the CNN in some form? Like I know that like at least, well, with CNN there's an assumption that there's some sort of like local correlation between pixels, I guess, in some ways, and
I've seen people do that actually, to analyze the graph. I've seen do that. I don't know how it works in real world.
So I see one problem with that, which is that like when you take a graph and convert it into a matrix, you can permute rows and columns of that matrix, and it's still the same graph.
Yeah.
Right. So it breaks that local correlation assumption.
Yeah. Exactly. So you need to have a really, really large window, and probably not.
But I've seen the problem.
You can take the nodes of the graph and just relabel them. So node number 1 and number 10, I'll just switch them around. Right. It's still the exact same graph, the same connectivity, but now in your matrix representation, those two things that were on opposite ends and now that's switched.
But that's why graph neural networks, I think, became such a thing. I haven't played around with them yet. I really, really am dying to, because they look really powerful for this kind of thing. They can learn the relationships that go out step by step, and they don't require any kind of structure that you're talking about here.
I think that's why actually graph embedding become a thing as well. Yeah. Like this Deepwalk or the other one, these are become a thing to fit to those neural networks.
Yeah, and then you can just classify from there.
Some algorithms are super fast, like graph convolution is graph attention.
Oh yeah, graph convolution as well.
I think much faster than this.
If you have GPUs.
Yeah, that's like if you had GPU, like you had a different problem here.
Yeah.
Any other question?
Sort of say again, what like at the end of this, now you've got these graph embeddings, so you can feed that into a classifier or something.
Yeah. Like in some, again, you can use this information in different way. You can use it, like if it's an anomaly detection, you don't know, you don't have any label, you don't know what's going on. You can just simply use PageRank and like ask your expert to look at it. Like reverse PageRank, right? Because the page, like the lowest the rank is less.
Yeah. Look at the distribution. Sometimes you end up seeing something kind of binary.
Yeah.
So it's like, look at that little tiny bump. Let's see.
Exactly. Like here, like it gives you some sort of information. From now on, if you look at this area, there's something fishy. Probably, it's most likely something fishy happens here than like more than 5. Right? It gives you some sort of information like that, especially if you don't have any prior knowledge of what's going on in your data. The same with shortest path, same for Ego network. Right?
No, I was just curious about the embedding.
Oh yeah, with embedding you can fit it. It's
that's also kind of unsupervised. You're just learning something about the connectivity of the network and representing these nodes in this embedding space, and now like what maybe does it yes.
Again, to be honest,
if it's just hopefully it's extracted some useful information, now I'll put it into a supervised classifier, and if it's useful, it's useful, and if not, then
the promise of embedding is to capture all this information I show you one by one in that one vector.
So you're doing representation learning, and then you're able to say that these two things are very similar, so the cosine distance shouldn't be very big.
Yeah. So the promise is like all this information is somehow sit in the embedding, and that's how it works. That's why I'm really interested in the other one. What was the name? The DeepGL. That's why I'm personally really interested in DeepGL, because especially with Deepwalk, as you said, you don't know what is it. It's just like it gives you some information. You don't know it's correct or not. You pass it to your model. It's iffy. The DeepGL one, the promise is it gives you information about the features. You can understand like what the features are. So it probably would be better use for us. But yeah.
So don't forget there's a survey to fill out. Pick your favorite teacher.
Yes, sir.
I have a quick question.
Yeah.
It's from a different sort of problem space, but I imagine you guys might encounter it in both cybersecurity and fraud detection. If you have a bunch of nodes and the graph is described by edges that describe interactions or candidate interactions where almost non-existent one would be somewhere around 0 and a very strong one would be up around 1. And you know that there is likely a network in there, but you need to choose what constitutes a true edge or not. Do you ever run into these sorts of things?
So it sounds like you're creating a threshold for like, this is just noise.
Yeah.
So I mean, some people can go from weighted networks to just unweighted networks, so it just becomes 0 and 1. But you have to pick the threshold that makes sense.
Or even keeping the weights in there.
Yeah.
And so in some, like in paper, I haven't been in this space for a long time. Like some people just pick thresholds, or they use standard sort of statistical descriptions. But are there any? Do you guys run into this problem space at all in some of your work?
I usually when something like that happens, I ask business to sit to me, somebody that knows those data, like some security expert or fraud analyst expert, somebody work with this type of data from different point of view, right? I usually ask sit with me and just walk through that information, and instead of setting threshold statistically true, setting threshold that business true.
Yeah.
I usually work around this.
Yeah. It can also be used, I think, although I could be wrong in this, in some kind of hierarchical Markov clustering. So you're trying to do clustering in a graph, but maybe these are weighted edges, and maybe you really only want to have the really pure, strongly connected ones at first cluster, but then you're open to a slightly fuzzier cluster, so you lower your threshold and keep doing that, and you get fuzzier and fuzzier clusters. So it's used in data science. We were playing around with it for a bit in a problem that we had, but we decided that Markov clustering didn't actually suit the graph structure. that we were dealing with. So you have to be aware that, you know, the algorithm that you're using, does it actually fit the graph structure? But yeah, you can.
I never had this issue before, to be honest, but these are the solution I can think of, maybe.
I was just wondering if maybe you guys have some machine learning enabled some things.
Oh, yeah.
Okay.
No, not that fancy. Like, and because we are not a research group, we do sometimes some novel models, but our promise is to help business to make their decision making easier.
Yeah.
Right, so we try to. That's why we like involve business a lot of time as well. If meanwhile we come up with an excellent idea that is publishable, patentable, we do that. When, not if, when we come with the ideas. Yeah. But yeah, like if we don't encounter anything or business doesn't have any problem, we don't touch it for now. Again, for now, I think maybe we have research team that does that for us. That's actually is really interesting problem, I think, to be honest. I don't know how to solve it.
Thank you.
Any other questions?
For the time, like, just going back to the theory stuff, like when you actually, even for this particular case, if you had time data, for example, like, have you experimented with like applying some sort of time series data of the graph, like
just move it mainly dynamic?
Yeah.
Not here, but I did on my work. It's a really, really, really hard problem to make it dynamic, especially if it becomes really big as well. But yeah, like it depends on the time window you choose. We make it our graph. How should I say? Real life, but we make it dynamic because like you cannot you cannot create a graph for now and detect a fraud for 6 months later, right? You have to evolve your graph and just dissolve the previous one, moving a slide. So we do that. But again, it depends on what you want to solve. Even like that time windows, it matters because again, you might lose the connectivity here. Or like in the money laundry case, especially, it matters to look at what type of the time window. And does it even matter, like if the money comes back within 3 months, are you care? Like it happens like all the time. It's normal life, like the money changes. But if it comes like 2 months, right? It like the time window, like it matters. But again, it's business by business, model by model. Like in the spam detection, we don't care much, right? Because from today to day after, it's probably like everything changed. Like the website we rank and everything is just like out of service right now. Like it takes like 2 or 3 days to shut them down. It's just done. So,
like network activity, say maybe it would be important, but it's also would be just huge computational problem. So. Yeah. Well, thank you guys.
thank you, guys. Oh, it's done.
Yeah, we're pretty much at 9.
Yeah.
So.
Can I bell now?
Yeah.
Okay, so before we close that off, please take the survey. Thank you.
Thank you very much. If you have any questions, like I'm not expert on these things, but if you can help, like we are in the Slack channels, and they connect us on LinkedIn as well, or yeah, and the LinkedIn,
I'll
please.
see you, whatever you want.
Yeah. Thank you very much. It's good to see you. Thank you very much. Thank you.
Sorry, I didn't have people.